Thank you very much. Hi, everyone. Good morning. Hope you can hear me. So, Sustainable Energy Abundance for AI is the title of a white paper that we published last summer with many industry partners to advocate for a new playbook for sustainability for the AI era. So, what this paper does actually is captures our learnings from developing applied materials sustainability playbook by applying really systems thinking and taking a more holistic approach. Now, that's not, of course, how we started out when we first started working on applied sustainability strategy. So it was an interesting journey of learning. So what I'm going to do is I'll start by making the macroeconomic case for why we need to provide abundant energy for AI and why we need a new sustainability playbook. Because this abundance mindset is really a different approach to sustainability. And then I'll describe the three pillars of our new sustainability playbook. The three pillars are grid decarbonization, energy efficient computing, and connecting sustainability to business results. And then I'll close with a quick update on Applied's decarbonization progress. So, from a macroeconomic perspective, really the most important global problem is demographics. And in simple terms, what that means is there aren't enough people to do the work that needs to be done to drive GDP growth. So this chart actually shows that working age population growth is slowing dramatically. And global GDP growth, which is the second line, is correlated and is following the same trend. And projections are for the demographic problem to get much worse. So the implications of that are that there's going to be an insufficient workforce, slower productivity, just directly as a consequence of insufficient workforce. And then all of that is going to lead to rising debt. So, what happens when governments see the growth slowing is they feel compelled to respond with stimulus. And that stimulus typically comes in the form of transfer payments, lower interest rates, increased money supply, some combination of those things. The capital needed for that stimulus comes from new debt, which then increases the national debt burden. So, what this chart is showing is that the major economies of the world all have debt that is up to 5 times larger than GDP. Now, coming off the gold standard and Bretton Woods in the 70s means that it is increasingly difficult now to control this debt. Higher debt increases interest expense, and that itself then becomes a headwind for growth, particularly when interest rates are high. So this creates a negative feedback loop where more debt is needed to drive growth with diminishing impact. And that's called a debt spiral. There is nothing nice about it. Now, AI holds the potential to reverse this trajectory, especially when combined with robots. As I like to say often, AI times robots equals virtually infinite productivity, limited only by energy. So, what we really need is low cost, abundant, clean energy to solve the biggest global macroeconomic problems. Now, turning to AI data centers. This chart actually shows an analysis we first did in 2018, before there was ChatGPT. And when we first shared this analysis publicly in 2019, as you can imagine, we instantly became less popular. Now, we recently updated this analysis, but our conclusions did not change. And now we're finding that there are more fellow travelers that are embracing these findings and collaborating with us. So, what our analysis is showing is effectively that AI data centers alone would consume 10 to 15% of global electricity by 2030, up from around 2 to 3% recently. Now, interestingly, that is a similar level to the electricity that just lighting consumes today globally. Just to light up the world consumes about 15% of global electricity. And perhaps we can debate that AI could actually be a lot more productive than just lighting. And so this is where abundance mindset becomes critical. So we don't have to have those kinds of debates about which application is more or less important. But if we don't implement a holistic approach to sustainability, we think demand for electricity could easily exceed supply. So what we're showing here is slightly dated information. This is from the US EIA's reference scenario from October 2023 for electricity supply. And based on that, our estimate is that electricity demand could be higher than supply as soon as 2030, maybe sooner. Now, of course, AI is not the only driver of growth in electricity consumption. As the previous speaker was talking about, there is electric vehicles, there is blockchain technology, there is tokenization, there is other, broader digital transformation, all of which will increase electricity demand. So our best guess is a lot of the modeling that was done for this reference scenario that we're showing here was probably done by energy analysts that may not have been fully taking into account the potential of digital transformation, AI, and a number of the technologies that are here today, but then also going to come in the future. So this is our playbook based on the approach that we used internally at Applied Materials. It's made up of three pillars: grid decarbonization, energy efficient computing, and monetizing new opportunities. Grid decarbonization is really the big new piece that we observed was missing in the previous industry playbook. Now, it should be obvious that consuming electricity from the grid assumes the emissions profile of the grid itself. Yet the previous industry approach focused on offsetting those emissions sourced from the grid instead of modernizing the grid itself. So that's the first pillar. The second pillar is energy efficient computing. Now, this is actually what our company, Applied Materials, is very well known for enabling, because we make the big machines that enable virtually every semiconductor chip that is made, including the most important and most valuable chips that are powering AI. So that's core to our strategy. It's core to our sustainability strategy. Monetizing new opportunities really connects the sustainability back to business results and effectively makes the playbook sustainable. So we'll talk about that. So this is the first pillar, grid decarbonization. And we believe decarbonization of the electricity grid is the single most powerful lever for semiconductor, AI computing, and other technology companies to reduce their overall emissions footprint. It not only addresses scope 1 and scope 2 emissions, but also tackles a large portion of scope 3 emissions. So this chart provides a deeper look at the components of Applied's scope 3 emissions as part of our baseline projections for 2040. The biggest component of emissions is grid decarbonization, which is really the first big bar next to the yellow bar. And it's based on really how clean or dirty the grid is in locations where Applied's equipment is used for making chips. And this would not be surprising to you. Scope 3 is 99% of applied total carbon footprint. Now, the conventional approach to sustainability overlooked the electricity grid, but our approach focuses on three essential upgrades. First, make more energy from solar, wind, nuclear, and yes, even oil and gas. Second, upgrade the delivery system, modernize power lines, stations, and controls. And third, make the system smarter, use technology to better manage energy usage and reduce water wastage. So, recent announcements from cloud service providers building out the AI computing superstructure really starts to highlight the importance of grid decarbonization. They are in many ways following this new playbook that we're advocating, and now they're collaborating with us to take this approach further. So we're observing two important changes. First is the shift toward clean nuclear power. And second, in some cases, like Google, for example, also working with grid operators to put together a holistic and end-to-end plan for electricity sourcing. That is a huge change from the industry's previous approach of just buying clean energy and using carbon offsets, because that approach didn't directly address the grid constraints. So, the next pillar, core to our fundamental strategy of the company, is energy efficient computing. This chart was actually prepared by TSMC, the largest semiconductor foundry, one of our largest customers, and it shows energy efficiency of computing over time on a log scale. The semiconductor industry has delivered a 10,000x improvement in energy efficient performance over the last 15 years. But as computing requirements for AI continue to increase exponentially, this framework suggests that another 10,000x improvement in energy efficiency will be required by 2040. But the old semiconductor playbook that got us here is no longer working well. And the industry is shifting to a new semiconductor playbook to deliver this energy efficiency. So this chart shows the computing performance improvements over time. This is actually taken from a popular computer architecture textbook written by Hennessy and Patterson. I studied from this book 30 years ago. This book was fully revised and republished in 2017 to point out the end of classic Moore's law and a shift to what's called domain-specific architectures, basically optimizing the chips for the applications that they're designed for. Now, for 50 years, classic 2D scaling Moore's law served the industry very well. Basically, this idea of making feature sizes geometrically smaller. But now it is no longer working like it used to. It has become very complex, very expensive, and the benefits are diminishing. So as we advance further in the era of AI and IoT, a lot more emphasis is being placed on architecture changes to drive power and performance improvements, not just 2D shrink or 2D scaling. So this is another illustration of the shift to the new playbook. In the good old days of Moore's law, PCs and smartphones were getting about 2x improvement in performance just by making the feature sizes of the semiconductors smaller and smaller and smaller. In the AI era, the industry has shifted to architecture innovation with the help of what we call materials engineering. That includes both computing architecture and device architecture, and it can drive much bigger improvements up to 2500x compared to the 2x that you got with Moore's law. Now, we've already seen a very big shift towards GPUs for AI, and NVIDIA has become the largest company in the world because of this. But now there's a shift taking place toward custom ASICs to further optimize energy efficiency. That's a change in computing architecture. But there are also major inflections taking place in device architecture. Now, materials engineering is really what is used to create these devices. And so that's why materials engineering innovations are playing a fundamental role in powering AI computing. So we're showing some examples here on this slide. Gate-all-around transistors are the next major advancement in leading edge logic technology after FinFET. This is the technology that's used to make the chips for AI. Semiconductor fabs are ramping production of this gate-all-around for next generation AI computing. Now, with this GAA and backside power delivery, transistor efficiency is determined by precise combinations of nanoscale exotic materials that can only be done under high vacuum with Applied's most advanced integrated materials systems, IMS. And the interfaces between these nanoscale materials really determines the electrical properties of the devices and the chips, and ultimately their energy efficiency. So shifting to the third pillar, monetizing grid opportunities. Now this chart shows our estimates for semiconductor revenue opportunities targeting transformation of the electricity grid. So we have estimated that the semiconductor revenue opportunity from grid transformation split across generation, distribution, and transmission is around $50 billion by 2030. So if companies look at sustainability merely as a compliance obligation, we think management teams and the board of directors focus on fulfilling just the minimum reporting requirements. And we have observed this firsthand as we were developing Applied strategy. However, if we can show a connection between decarbonization strategies and then tangible business opportunities for revenue growth or cost savings, companies are much more motivated to make bigger investments. So that's the third pillar of our sustainability playbook, connecting sustainability back to business results. Now, before I close, I would like to share our decarbonization progress at Applied Materials, starting with Scope 1 and Scope 2, which is shown in the chart here. In 2024, Applied's total energy use increased 6% year over year as our revenues increased and our real estate portfolio also expanded. However, our greenhouse gas intensity decreased as measured against employee headcount as well as against revenues. And this intensity reduction was driven by a systematic approach taken by our infrastructure team to optimize energy efficiency of our facilities and manufacturing sites. And then shifting to Scope 3, this chart shows Applied Scope 3 emissions compared with revenues. Scope 3 emissions decreased in fiscal 2023 and 2024. And we believe that this reduction indicates a positive impact from product efficiency as well as clean energy gains, even as our business grows. And the main drivers of this reduction were our product mix and early integration of what we call our eco-up solutions in the product sold. So these are sustainability-focused solutions that actually command good value from our customers because they are also very interested in extending their own sustainability roadmaps. So as I close, I'd like to invite all of you, regardless of where you are in the ecosystem, whether you're chip designers, data center operators, fab providers, equipment makers, grid operators, policy makers, we want everyone to come together to align technology, policy, and capital towards really a shared objective, which is what we call sustainable energy abundance. Thank you, and I'd be happy to take questions.
Thank you. And eyes-opening and excellent talk. So now time for a few questions. So, okay. So first question is that why don't you consider energy storage in monetizing grid opportunities?
It's an excellent question. And we have actually a group that does look at energy storage. I think, that's more on the R&D side of things. But as a company, we can only focus on a limited set of opportunities. Again, connecting back to what drives business results for us, we make investments in more technologies that others can then develop, including storage technologies. And there are many other things that we are looking at making investments in also along those lines. Uh, that I probably can't mention here today, but for sure, I think storage is a very important part. It was an overlooked part in the previous playbook, and something that we should collectively focus on going forward.
All right. Then, um, yeah, do you think that only price of energy will limit energy usage of data centers, meaning that even with the new inventions, all energy will be used if it is economically wise?
Yes, we think the computing demand is insatiable. We think the productivity requirements of the world to solve the global macroeconomic challenges, as I showed, is also very, very large. There is a very big opportunity to drive up productivity as the population ages. You need machines to take over and do a lot of the work for us, and that's going to require a lot of energy. So, really, I think what we're chasing together, if I was to name it, what we're chasing together is zero cost energy, right? We're infinite compute and zero cost energy. That's really what we're chasing. Now, when we get there, how we get there, we have to go innovate. Um, but if you just provide energy efficiency, that is not enough because it's actually going to drive up increased application usage, increased penetration of the technology, ultimately driving up energy usage, right? So we can't just focus on one of the pillars. We have to focus on all three of them. We have to also make more energy. We have to make abundant energy. And we have to be smart about the transition. We can't just shut down one form of energy before the other form is ready or before there's enough storage. So I think some of the challenges we've noticed with the previous playbook, we think will be addressed by the new playbook.
All right. So thank you, Sandeep. I guess it's time to move forward. But thank you once again.
Thank you very much.